today. I started with, I think, Quentin on Monday, and Chris on Tuesday. So we'll just start with Chris today. Alright, Chris. So think it back over. If I have, there's only 3 of you. So if I have a non-metal and a non-metal, what type of bond is between them? Non-metal, non-metal.
Covalent.
Covalent. You got it.
Oh, there's a burn on my finger.
Sorry. Oh, remind me to move it later so Jimmy can swatch the class.
Did you remember yesterday?
I did. So I remember to look at it. But make sure to remind me so that way I won't forget. I feel bad whenever Jimmy has to watch the ceiling.
My arm isn't warmed up.
Alright, if it's between a metal and a non-metal, what type of bond, Ethan? Metal and a non-metal. Let's not do that today because it takes too long. You've got to know them, Ethan. Between a metal and a non-metal. Stop stealing my pens. Final answer?
Yes.
No. First, let us go just a minute since I was just
Oh, come on.
Ionic, metal and non-metal. Metal and non-metal. You gotta memorize it.
He said
I did. I just threw something out.
Good job. Alright, if it is between a metal and a metal, what type of chemical bond is that?
Start with an M.
It starts with a letter. Metallic.
It says starts with an M. Actually, where did it go?
So it's good to make sure you know them.
Kobe.
That was a good art.
Kobe.
Well, you got a point. So that's good. You're beating Ethan. Sorry.
It's like that vine avocado thing.
Alright, Ethan. Which one is characterized by the sharing of electrons? Because both of them want it. That is covalent.
He's doing homework.
Oh, I'm not.
Oh, he's doing the crossword.
homework
He's doing a crossword in the back of his head.
You spill my dice. But you cleaning them all.
Are you kidding me? That was on 20.
Watch out for my board. Don't did it. Alright, at least
That
you
was
got
a
5
hate
points.
crime.
At least it was 5. Alright, what type of bond is characterized by delocalized electrons, or a sea of electrons, because nobody wants them? That's metallic.
Felt that. I'm gonna make that joke till we stop wondering about it.
Alright. What do you call a bond that is unequal sharing? So it's covalent because it's sharing, but unequal.
Start with a U.
Unequal.
Polar.
Polar. So that means one of them's stronger
I was
than
gonna
the
try
other.
and play you again, but it ain't work.
No, I'm ready this time.
Kobe. Kobe.
12. Alright. Just so that we can go through this really quick. Let's see, how many electrons are being shared in a triple bond?
6.
Yeah, we're gonna move on to this. Because I don't want to ask. No, but I have other stuff to get onto. I just don't want to ask like how many in a single, double, or triple.
Why? That's like extra rows.
I know, right?
That's four.
That's on the line.
That's 13. That's on the line, so that's all we get.
It is on the line, baby.
We'll let you read Kobe.
I'm gonna get nothing.
Yeah, that's why we let you read Kobe.
Alright, what do you call it whenever you have atoms that are covalently bonded together, but they make a larger pattern? Starts with C. I haven't asked it this way in a while, so I'm checking. They're bonded together into a strong unit.
Oh, yeah.
Okay, so they're covalently bonded, but they're a larger substance. I can't give the examples, but that's my next question. Alright, so just the next question?
Chemical bond?
Nope. What do you call it?
I know what the next question's answer is going to be.
Wait. What do you call it whenever you have atoms and molecules, they are covalently bonded, but they form up a larger structure? It's the same patterns over and over again. Alright, no one got it, so write it down, but it's covalent networks. Alright, now what are the 2 examples of covalent networks? Diamond and quartz, good start.
Kind of easy question. Yeah.
Well, the covalent network was hard,
Yeah.
but I haven't asked that one in a while, so I gotta check.
Kobe.
I'm sorry. Don't dip my board! Be careful. more positive and more negative in? What do we call the molecule that has a positive in and a negative in?
Let's start with.
D. Because there's two regions.
Oh, is it like
Okay, what means two?
die?
Di, and then magnetism. What term do we use to refer to the fact there's a north and south?
Dipole?
Dipole, I'll take that. But dipole, we call it a polar molecule or a dipole molecule. It's a different terminology.
Yeah, that's in the North Pole.
No, I
And
thought
the
it
devil
was
lives in the
South
south.
Hey, look at that.
21.
Be quiet!
Alright, what symbol do we use to represent that partial charge in a covalent bond?
What?
What symbol? It's that weird looking G thing, but what do we call that weird looking G thing?
Lowercase alpha.
Good stuff.
I like you cut backwards though. I like you cut G.
Come on, I thought it was going
Okay, well,
bruh.
17. It's not horrible.
That sounds.
Okay, that one's off.
No, it's not.
That's all.
Alright, Quentin, I think you get this question every single time. What do we call the diagrams that you draw on the board?
I was thinking that.
I thought this is like a third day in a row.
It is Lewis structure.
Lewis structures. I'll try to see if I can mix it up so you don't get it next time.
Kobe.
But you get 16. Alright, what do you call the electrons whenever they're not locked into place?
That was like a head out.
What?
Where's our
D.
D?
D. What do you call the electrons whenever they're not?
Delocalized.
Yep, delocalized.
Sorry, say I'm thinking 11. That bar was like, that door was like, I'm gonna head out.
Sorry.
I actually got him.
You almost got a circle in the ball.
Alright, what do you call the bonding situation
Wait, you're supposed to stick the darts here.
now? You can, but I mean, it's magnetizable. So stick them on a metal does it too. I feel like if sticking them on metal makes them hang on to it longer. That's how come I put them on a metal object, trying to help them remagnetize. Alright, what do you call the bond situation in which electrons are shared by more than two atoms? So not what's the name for the electrons, what's the name for the situation? D. Delocalization or resonance, because it's vibrating back and forth. Either way works.
Much better.
Please follow.
What the
It
world?
only does that for you.
It was like,
Alright, what do you call this type of shape? Just hold it so Jamie can see it, barely. Alright, Jamie, and Quentin. What do you call this type of shape? What was it? Good. That's the choosing one. What's the other one? T? Okay, it'll be okay, so for like today, I'll help you out with that, but it's tetrahedral is the
Alright.
3D shape. Okay.
Cathedral.
Tetrahedral, Jamie.
Lower mass.
I'm trying to watch it in the video because make sure it's in the shot.
oh wait, I was waiting for that 18 on the ball.
Yeah.
I think you won.
Alright,
You just got more points in that one story than I have.
what do you call this shape?
Let's start with.
To where there's two atoms bonded and there's two regions of unpaired electrons.
Let's start with
It starts with an A.
an A.
A.
Is it a weird name?
No.
You were talking about. Okay, you were supposed to say
Don't give
that,
him
like,
any
that
hints.
you were supposed to say that this shape was supposed to help you out yesterday, and I don't know how it's supposed to help you out.
the Harry Potter ball.
Yeah.
Which again, I don't know how that helps you, but
It looks like the Quidditch craze.
I know it.
I don't know.
I don't know how that helps you to remember the names.
The autistic butterfly, I know.
You gotta know the name. You can't just know it as it looks like.
Well,
Autistic
I know it.
Alright, so just the next,
Anthony Edwards.
just the next person in line then.
Angular.
What?
Angular.
Angular. It might help you to remember it with the fish, how the fish has a little like dangly leg. Maybe that'll help you to remember because it looks kind of like that.
I'm gonna go plug myself. I'll see you all later.
Alright,
Plug
what's the
yourself.
name for this shape? Whenever it has 3 electrons bonded to it, but has an unpaired region of electrons. What do we call that? It's
Clean.
hot on your jacket. Please be careful.
Let's start with
Alright, so it has 3 atoms bonded to it. So trigonal, and then which one is it? Is it the flat one, or is it the flat one-dimensional, like one plane one, or is it the pyramid one?
Pyramid.
So what's the name?
Pyramid.
Close enough. Trigonal pyramidal. Don't be too much. Get a little bit too excited. Ooh. Okay, well 15 now. And that's close enough to being in 5. You can flip it.
Okay.
Alright, what's the name for this shape? Whatever, it's 3 atoms bonded to it, but there is no region of unpaired electrons.
It's like that tri-plane thing, right?
I'll take that. Trigonal planar. So make it up for this one.
I think it's already top one. Already.
How many do you have?
94.
I had 25. No,
Yeah.
just kidding. I have more than 25. Just don't have time.
Alright, what's the name for this shape?
Linear.
Linear. Whoa, whoa. Hey, 10. Alright, if I have 2 atoms, what shape are they gonna have? Linear. Yeah, so if
What?
you have 2 atoms, it's always
Get
gonna
the
be
easy
linear.
one.
You already said it right there.
Let's go. Let's go.
Alright, add your points. Anyone think they got close to Quentin?
I did.
Alright, who's got 75 or more? Alright, oh. Alright, who's got 80 or more? Alright, Quentin wins. Alright,
I had 23.
Mine too. Alright, let's go ahead and let's get back into it. Make a note of the shapes as we go through it. We'll practice drawing these again in a minute, but I want to talk about polar versus non-polar molecules really quick for it. Alright, so your book gives the example, it's on page 138, 139. Alright, your book gives this one as the example one, so let's start practicing out with this one. Alright, how would I draw this one's Lewis structure? What do I do? So I'm going to tell you right now, this is the one in the center, but how do I draw it? What do I do? We'll help each other out for it.
Put a
Alright,
C in the middle.
wait. We'll start off with Chris. Alright, Chris.
Put a C in the middle and put O and O.
Alright, so how many
Thank you.
how many electrons does carbon start off with? I gotta know this first. Alright,
6, 8, 4.
you can look at your table.
4.
4. So 1, 2, 3, 4, just for right now. How many does oxygen start off with? 6. So 1, 2, 3, 4, 5, 6. I'm just drawing. So that way I'll remember where they go. Alright, so is oxygen happy right now?
Yes.
Is it?
Yes.
Why? No.
Because carbon is giving him 2.
Good job. So, what type of bond is that? Okay, so oxygen sharing its 2, carbon sharing its 2, so there's 4 total, so what type of bond? What type of bond? Double. So, alright, 1, 2, 3, 4, I'll draw like that. So, here's one of oxygen, make sure that you can see this. Alright, so here's one of oxygen, one of oxygen. Now, is this oxygen happy? Alright, so obviously that means this one has the same thing as well then. So 1, 2, 3, 4. Alright, so is this oxygen happy? Alright, so is carbon happy? Yeah, so everybody's happy. Now keep in mind, since this is between oxygen and carbon, is that going to be equal sharing between them? No, who's going to be stronger, oxygen or carbon? Oxygen. Now what's that term that means that they want electrons more? So they're pulling it closer towards them.
Let's start with.
So it's an E.
The second word solid.
It's one term.
Oh.
Fluorine's the strongest so that might help you out to remember.
Energy neutrality.
Is that your answer?
No,
Alright, Gwen, do you remember? Electronegativity. Electronegativity. It's one word.
What a guess.
Electronegativity. Alright, so
Good.
remember, we draw the little arrows to help us and to remember that, okay, the oxygens are going to be slightly more negative because they're pulling it closer to them. What's the little symbol we use to draw that to represent a partial charge? Because they're still sharing, technically.
The G.
The little back, no, what's the technical name for it?
The reverse, the lowercase delta.
Good job. So on a little g over here, or no, I'm saying reverse. Lowercase delta over here. Now keep in mind, if you're going to have a polar molecule, that's whenever you're going to have a positive region and a negative region on opposite sides, or it's unequal sharing all around the molecule. If it's the same charge all the way around, then it's not considered polar. So make a note for that. So a molecule that has symmetrical distribution of polar bonds will have no net dipole and will be non-polar. So this one on either end, it's both partially negative. So would that be considered a polar molecule or a non-polar molecule if it's the same charge on both ends?
Non-polar.
Non-polar. So that's what it's talking about. That okay, even though this one has polar bonds, doesn't mean the molecule itself will be polar. It just means that okay, that yes, there's polar bonds, but if you're looking at the whole molecule, is the molecule polar or non-polar? Because it's the same charge on either end, then it's considered non-polar because there is no positive and negative side. It's one charge all the way around. Kind of like if you get little circle magnets that are all like one charge, like North Pole or South Pole, that's the same idea for it. Alright, anyone have any questions about that idea before we practice a little bit more? Alright, your book gives you another example with ammonia, so NH3 is another good practice. Alright, so in center ones, what's the first thing I do?
Check to see how many ends, or put it in the middle.
Good job. Alright, and so I have hydrogens around it. I'm just gonna draw them like this. It doesn't ultimately matter. Alright, so how many does how many does each hydrogen start off with? You're gonna do this in lab tomorrow, so I'm making you go through it slowly because I don't have a whole lot of time to help you tomorrow do this, so you gotta do this kind of quick. Okay, so one each.
And they're happy because N has 5.
Good job, but you stole this question, so how many does it start off with? 5. Alright, so what type of bond are you gonna put between each of the hydrogens then? Good job. E. So this is one of nitrogen, this is one of nitrogen, this is one of nitrogen. So what do I do down here then to represent that? Because is all of nitrogen being locked in right now? Yeah, you put 2 dots. E. And then I draw typically a balloon shape, so I will remember it's a region. As a side note, what shape is this? Chris? What shape is this? It's 3 electrons. 3 atoms bonded to a central one, and there's a region of unpaired electrons. There's 3.
Trigonal pyramidal.
Pyramidal. No. Alright, so it is as a side note. But hey, you gotta know this because again in lab tomorrow you gotta know how to do this. So it's the shape. Alright, now so because of this, will there be is there equal sharing between hydrogen and nitrogen? Nope, nitrogen will want it slightly more, so I'm not going to draw the arrows this time, so it'll be slightly positive, slightly positive, slightly positive. Will this be slightly positive? Quentin? No, this will be down here slightly negative. They're still down here, but they're negative. So because of that, does this one have symmetric partial charges all the way around it then? It has positive or negative all the way around it? No, it has a region of negativity. So, will we consider this a polar molecule or a non-polar molecule? Polar. It's not your turn.
Polar.
Polar. Alright, how many questions about this?
Nope.
Alright, let's do one more as a practice.
Take the review again.
Alright, so this one does not obey the octet rule because fluorine's being a bully.
Why you bully?
Alright, so what type of bond is this? And the side note. Chris?
Can I just get this question?
No.
Press B.
Trigonal.
No. What type of bond is this? Single, double, or triple?
Triple. Double. Single.
Single. There's one line that represents single bond. Alright, why though? How many electrons does fluorine start off with? I'm going to stick with you, Chris, just to make sure you got this. 7. So how many more does it need? 1. Let's talk about the single bond. Alright, now for this one, will there be equal share between fluorine and boron? Ethan. Yep, so all these will be partially negative because fluorine each wants some. Now, there is no region of unpaired electrons, so they will try to start out from each other as much as possible. What shape is that?
Trigonal.
What?
Trigonal planar.
Planar, yep, that one because it's just in one
Yes.
So will this one be polar or non-polar?
Non-polar.
Non-polar. Good job. Alright, anyone have any questions about this before we move on from this again? Because your lab tomorrow will also ask that as a question. That's the reason why we gotta practice with them. Throw in dark time as friends. Alright, let's look over. Now, let's go over page 139, number 2. I know you worked this out as your homework, but I didn't ask yesterday if they were polar or non-polar. So, let's go back through them and let's say, okay, whether or not the molecule is polar or non-polar for it. So, for that first one, anyone remember what shape that is? For letter A. If you need to rework it out again, I can help you out for it, but again, you gotta know how to do it.
Tetrahedral.
Tetrahedral. So for this one, it's Si, and then you have the 4 single bonds for hydrogen all the way around it. Alright, so looking at this one, will there be equal sharing between silicon and hydrogen? No, so obviously each of the hydrogens are going to be partial positive. So will this be polar or a non-polar molecule? Non-polar. Good job. Alright, the next one is aluminum and then fluorine. Because fluorine's being a bully and forcing aluminum in this case to deal with it. So, what shape is this? Ethan? Oh, people have already answered this, so I want to make sure.
Trigonal planar.
Trigonal planar. Alright, so as it is written, will this one be polar or non-polar? Chris? Why?
Because it's negative. It's not, well, no. It'd be non-polar.
Good job, that is right, because each of these will be slightly negative, you're right, but it's symmetric, it's on all the sides. I didn't draw it, but technically they would spread out a little more like this, so it's symmetrically all the way around it. Alright, do we have any questions about this one? This one will also be non-polar. Alright, HS2. Anyone remember what this one's shape is? Or you can rework it out really quick if you don't remember how to do it.
Linear.
Oh, let's figure this out then. Let's figure it out then, because we have one person say linear, one person say angular. Who wants to work it out then? Well, Ethan raised his hand. Alright, Ethan. So, S is in the center. I'll go ahead and tell you that right now. Where do you want me to put the H's?
Inside.
Alright, so, this is a single bond, right?
Linear.
Wait, let me finish. So this is a single bond, right? Or do you need something else there? Wait. Okay, so hydrogen brings over how many?
1.
Okay, sulfur brings over how many?
5.
Okay. You sure?
6.
Yeah, so, okay, I'll draw dots right now. We'll draw dots right now. Okay, so sulfur brings over 1, so what bond is this? Like single, double, or triple?
Single.
Single. So is hydrogen happy?
Yes.
Okay, so each hydrogen is happy. Alright, now, keep in mind, sulfur started off with 6, so it has sharing here, so sulfur is now happy, correct? But I have 2 regions of unpaired electrons, so you have made this shape, but you do it like this, so it is an angular. So yeah, even though, let's be careful, that's one of the reasons why tomorrow, as you work this out, you want to draw your dots, so I would help you to see, oh, it's this shape, and I'm just drawing it like this.
So
I can't draw it, pop it out in a 3D.
If it didn't have those dots, it would be linear.
It would be linear. But sulfur has the dots. You can't just go yeet out the dots and call it linear. You'll be wrong. So make sure you're careful. Alright, so for this one, would this be, okay, so for this one, would there be equal sharing between the hydrogen and the sulfur? Quentin?
No.
No, there are not. This one would be partial positive. Well, that's not positive. Partial positive. So, would this be a polar or non-polar molecule, Quentin? Would what?
Non-polar.
Non-polar? Fine. Alright, because I have a region of negativity with these what? Polar. Yeah, because these will be partial negative, partial negative. So I have regions of partial negative and partial positive. That's why that one's polar. Alright, you don't have any questions about that? Alright, well, let's look down at the next one. HBr. Alright, Ethan, do you want to say what this one would be?
HBr.
HBr. It's 2 atoms.
Linear.
Good job. Alright.
So better than you.
So, it's okay. A little bit, but not a ton. Alright. So, because of, okay, make sure you're not getting overly distracted. Alright, so, will there be equal sharing or unequal sharing? Between hydrogen and bromide?
Where's bromine?
Bromine, sorry, I said bromide. Bromine is in group 7.
No, it's unequal.
Unequal, so this one would be partial negative, partial positive. So, would the molecule be polar or non-polar? Polar is correct. Alright, so the next one is selenium and dichlorine. You okay, remember what shape that is?
Dichloride?
Selenium and dichloride.
Yeah.
That is,
Or you can rework it out if you want to.
no, it's angular.
I thought
What?
it was dichloride.
Yeah, technically. But I'm just saying it, I'm just with the two of them, but yeah, technically for this one it would be selenium dichloride. You are correct. Alright,
Is it angular?
it is angular because selenium starts off with 6 and then it bonds to each chlorine. So you can draw it like this or the other way. I'm not gonna sit there and tell you, oh, you drew them on the wrong side. Basically, I just drew it like this, so it doesn't matter. This one is angular. Alright, would this molecule be considered polar or non-polar? Work a little bit faster now at this point.
Polar.
Which one?
Polar.
It is polar. Now, you might think, okay, well, this one's partially negative too. Yeah, but they're not going to be the exact same as regions of negative, and so because of that one, because I have different strengths of negativity, that's why this one is considered polar as well. Alright, anyone have any questions about that? We're going to skip F because F have delocalized electrons and that makes that one funky, so we're going to skip that one. Alright, G, anyone want to guess
Wait.
what shape this is? Alright, Ethan? Or do you remember?
Trigonal. Pyramidal.
Why? You are right that it looks like this. How many does phosphorus start off with?
Why'd you write eight?
5. Or trigonal pioneer.
If it starts with 5 electrons? I can't hold up 5, I'm going to drop my chalk. So, here's 1 electron here from phosphorus, 1 electron here, 1 electron here. Where's the last 2?
So it's right there.
Trigonal
Trigonal pyramidal.
pyramidal is correct for this one. Alright, so this one, Chris, will this one be polar or non-polar? What?
Polar.
Polar, because this one's negative. Now this one will also be partially negative, but since it's different strengths, it's still considered polar. Alright, anyone have any questions about that?
No.
Alright, last one. Carbon what's it mean? Is that one? Carbon trichloride. What's
Tetrahedral.
Yeah,
I was gonna say it
know.
anyway.
I went to go say, I was like, oh, I know what
I was
I
gonna say
did.
it anyway.
Very strong. Alright. Whoa. This is why dyslexic people should not try to do multiple things at once. People just make multiple poses of it. Alright, so tetrahedral obviously. Alright, so was there this one be polar or non-polar? Just guessing. Why? Yeah, because it's all the same all around. These would all be slightly negative. Alright, anyone feel like that they need help with this or they think that they got it at this point?
Take the quiz.
Nah, you gotta do lab tomorrow. Gotta do that one. So, just because again, for lab, and that'll be part of your homework is to read over it, is I don't have a whole lot of time tomorrow to figure out the shapes over and over again. If you want to build as many molecules as possible, you're gonna have to work really quick through that section. So if you want to go ahead, what?
We should take the quiz that you have assigned today.
I'll go with that.
Alright, you have questions about this? Alright, let's go ahead and let's move on then, getting into a little bit of the next section for it. So, the next section is talking about intermolecular forces. So far we've been talking about chemical bonds. What is one type? Well, first off, what is a chemical bond? That's a covalent bond. So, covalent's an example of it, and metallic. But what's it?
Central.
What is the definition of a chemical bond? What's it holding together?
Electrons.
Partly, what else though?
I like core.
The what? Not quite. Alright, anyone remember what's the definition of a chemical bond? Y'all know this.
Bonds have chemical.
It's all the bonds
It's something the bank gives you if you need money.
Nope.
Something that
Whenever
physical science is service.
okay, make sure you're not getting distracted. It's whenever holding it's holding the molecule together. So this is the bonds, like for this one, it holds these atoms together as one unit. This is one molecule. This is carbon tetrachloride. So this is one molecule, but it's making them all stick up together for it. As a side note for sharing, what type of bond is that?
Single.
Okay, single, what type though? Ionic, covalent, or metallic? Between a non-metal and a non-metal?
Non-metals,
They're all
covalent,
Good
I
job.
thought carbon was
It's okay, yeah, it's one of those. Just one reason, you can just use the periodic table to look really quick as well. So Jamie, if you have your little cheat sheet of periodic table, you can use that as well
She
for
has
it.
tons of them.
What?
She has tons of them.
She might. I've seen a bunch of them too. I keep sending, yeah.
You said your cheat sheets.
I send her like the periodic one since she doesn't have a periodic table. Send her a copy so she can use it as well. Alright, so these are intermolecular forces on page 139. This is holding individual molecules to other molecules. So this is one reason why like water sticks together is that the water molecules are attracted to each other. Does anyone remember, okay, this term is not in this book, does anyone remember what's the term that means that molecules of the same type want to stick together? This is way back there in physical science. If you don't, it's okay. But that's called cohesion, whenever they stick together, and then adhesion is whenever they stick to some other substance. Does anyone remember what's that curved substance that forms it on the inside of like straws sometimes whenever it looks like the water is shimmying up the sides? Anyone remember?
Spit.
What?
Spit.
Nope. Meniscus. So again, you don't have to know these terms, I'm just pointing it out to you. This is one reason why they
Meniscus?
meniscus.
Okay.
Isn't that a disease?
Think you
A torn meniscus?
what?
Or isn't that injury a torn meniscus?
That's a type. I believe that is a type of tendon or ligament. I know what you're referring to. I'm not sure if that's exactly what it's called, but I know what you're referring to. Alright, let's get into the page 139. So, intermolecular forces, these are forces between molecules that make them stick together. There are also 3 different types of them. So, this sounds very similar to covalent, ionic, and metallic bonds, but they're not. So, be careful as you're going through them. I put them all in one list because I didn't want to split them up. So, if you want to go ahead and mark them all in your book, you can for it. But there are 3 different types of intermolecular forces that make them stick together. Dipole-dipole force, London force, and hydrogen bond, but it sounds misleading because it's not an actual bond. Alright, next page. So, dipole-dipole forces. This one is between polar molecules only. Only between polar molecules. So, with this one, have dipole-dipole forces making them stick together. Is this a polar molecule?
No.
No, so dipole-dipole would not exist for this one. They're only between polar molecules. Remember, what's a polar molecule, Chris?
Polar molecule is one that has 2 different charges.
Yeah, it has basically 2 different
Yeah,
charge
equals.
ins for it. Your book, I'm trying to figure out. Alright, that one is acetonitrile. That's all that one. They're showing that one how it has the positive regions and the negative regions for it. And that's what causes them to be attracted to another molecule. This is another common one. This one is just showing you hydrochloric acid or hydrogen chloride or hydrogen chloride. That's what we say whenever we're not referring to it as the acid form. But it's just this. So as a side note, what type of bond is this?
Right here.
Okay, that's the shape, you're right. What type
Hydrogen
of bond is
chloride.
that?
Covalent.
Covalent. And then what type? Single, double, or triple?
Oh, single, yeah.
Single.
Single. And then would it be a polar bond or a non-polar bond?
Non-polar.
It's equal sharing between hydrogen and
I
chloride?
didn't say that. Non-polar. Polar.
Polar! Good job. So you have a negative N and a positive N for it. And so if you have them all next to each other, you're going to have them start to orient themselves to where it's partial positive N to partial negative N. That's what this picture is trying to show you. Lowercase delta. That they will start to orient themselves this way for it. Your book shows you a much better kind of 3D image of how they're all basically attracted to each other. But that's the reason why they only exist with a polar molecule. If it's non-polar, then they won't stick to each other because they're either all positive on the outside or all negative on the outside, and they won't be attracted to each other. Okay,
Why does that look like BB-8? Do
Well.
you know who that is?
I don't know.
It's a BB-8 bond.
Single.
It's a BB-8 bond. 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 It's a BB- Are you
Well,
a Star
duh.
Wars? Are you a Star Wars fan?
I'm offended.
Are you a Star Wars fan?
Yes. I'm not necessarily, okay, this is not related to chemistry,
Have you seen
but
every movie?
I have seen them all.
Okay.
I have not seen The Mandalorian yet, just because I just haven't watched that one yet. But I'm not a super big fan of
Mandalorian
Disney
is
Star
canon.
Wars. I'm not a super big fan of it. That's because I read the
It
books
ruined it.
growing up, and so I
You should-
love 1 through
You
6.
should try and watch them in chronological order. It makes more sense in the Disney movies actually become a little bit better. But
Because I read the books,
Mandalorian,
it's just hard.
did you know the books came out after the movies?
the original
I thought they
books. No, well, keep in mind that George Lucas, this is not what chemistry, sorry, Jamie. So then he directed 4, 5, and 6, and then he basically said, okay, anyone can write books. He had a couple people start off. He's saying, okay, I don't want to be stuck doing these for
You read
forever.
the Disney books.
What?
You read the Disney books.
Nope, I read the old ones. You can't hardly find these in books anymore because Disney said they're no longer canon, so a lot of people don't sell them anymore. But then George Lucas went back and wrote and directed 1, 2, and 3. So the authors that wrote the books, they understood that George Lucas had ultimate say because it's his story and it's his universe. But they could go basically and write whatever else they wanted. Now keep in mind, there's about a 10, 15 year gap between directing episode 6 and episode 1. So keep in mind, there's a bunch of books written. So in that time period, like I was reading Star Wars and I read a whole bunch of the series. There's the X-Wing series. There's a whole other like story plot with Luke and Leia and Han and all their adventures. So I read all of them.
About that.
Yeah.
But
keep in mind though that George Lucas, he would make the story up as he went. So that's probably the reason why there's kind of plot holes and stuff. That's one reason why Obi-Wan came back as I'm sorry, Jamie. This is why Obi-Wan came back as a ghost because George Lucas killed him off in episode 4 and then realized, oh, there's no way for Luke to know about the Iboga. They can come back as ghosts now.
Don't worry about watching Mandalorian because it's not canon. So if you're like big on if you don't really watch
I've watched them all.
If you don't watch non-canon stuff, there's not really much reason. Like if you don't watch I forget what the show is Disney XD for some reason.
You're thinking about the Rebels and Clone Wars.
Yeah, if you don't,
My
that,
sister.
which isn't canon. It's canon. It's just
Disney
long
said
time.
those are canon. Disney
said
kept
it.
those.
Disney said it.
Yeah, but keep in mind that even George Lucas, he told Cartoon Network that they could start making Clone Wars. That's the reason why I think Clone Wars is so good, just because they did a really good job following the original story.
I found it hard to watch it.
It can be a little bit difficult. Okay, we
Okay,
gotta move on. We gotta
back to
chemistry.
chemistry.
We gotta go to chemistry. Okay, so
You're right.
anyway,
Let's go off a nerd trail.
we
real
did.
quick.
Okay, so did you have an original question that got started on? You asked about that.
I said that
Okay,
once
anyway,
in
we're gonna move on.
yeah.
Alright, so anyone have any questions about dipole forces? I'm sorry, Jamie, for like wasting 3 to 4 minutes.
Well.
Okay, so anyone have any questions about the dipole forces? So only exists between a polar molecules. Now, you make a note though that even though these are charges holding the molecules together, this sounds very close to a type of bond. What type of bond, chemical bond, has the different charges or cations and the anions being attracted together? Quentin. Ionic. So your book points out that okay, even though this seems close to ionic, ionic is stronger because remember ionic is what's holding the molecule together. This is just holding partial charges from one molecule to another molecule. So make a note on page 140 that dipole forces are not nearly as strong as an ionic bond. Even though they're very similar, an ionic bond is stronger. Anyone have any questions about that? Alright, your book points out as well that the intermolecular forces, they affect a bunch of different things, like how they stay as a solid, liquid, or gas because it's the attraction of the similar substance. It also affects what substances will dissolve in another substance. Does anyone remember? Okay, I don't think we've quite talked about this yet this year in chemistry. We talked about it in physical science, so I'm going to try to remember what we've talked about in what class. But does anyone remember why water and oil doesn't mix or readily dissolve together? Okay, wait, you raise your hand.
Yeah, it's because the density of it, isn't it? Like the oil is more dense and less liquidy.
Oil's more dense than water.
Or less dense. That's why
Okay.
it sits on top. Like what is it called? The tension level of water.
Okay, so why does the water stick together more than the oil? Why does the water basically go, I don't want you, and pushes you up towards the top? Because
Oil has more electrons.
Okay, it has to do with the idea of water is a type of polar molecule and oil is not. So, getting back to that, we'll talk more about that. That's one reason why substances won't dissolve in other, like oil will not dissolve or spread out and diffuse into water because the water is all dipole or type of dipole force, talk about hydrogen bonds later on. So water is much more attracted to itself than it is to the oil. And since the oil is less dense, that's why it kicks it all up towards the top because the oil is non-polar. So that's how come your book's pointing out the intermolecular forces, they affect other things besides attraction. It affects things like gas, liquids, and solids. When will they condense or evaporate? It also affects who dissolves into what. It also affects the boiling point. Alright, what is the boiling point? I think we talked about this with state changes previously. Physical science also talks
Boiling
about it.
point of water?
But what happens at the boiling point?
Oh, yeah, the water starts evaporating.
So, for water, that's
It's like 106, isn't it? No, 106. Is it 130 something?
okay, I think you're combining 2 to 1. So, what is it in Celsius?
Celsius is like, is it in the 50s? What is it?
100. So 100
yeah, but
degrees, it's okay, it's been a
freezing.
while.
32
Yeah.
is freezing.
For Fahrenheit.
Yeah.
So, just keep in mind with temperature scales. But yeah, so, boiling point, this is whenever a substance only needs to overcome basically 2 things or 2 factors and that affect the boiling point for it. Intermolecular forces, how strong it's attracted to itself, and then also molecular weight, because it has to overcome atmospheric pressure pushing down on it to actually evaporate out. Alright, so, just make note of this one for double forces. Anyone have any questions about this one before we move on to London forces? Alright, London forces, they're named after Fritz London, which is way less cool than being named after London the city, but the guy's name is Fritz London, that's what's going on.
Named after what?
They're named after the scientist that basically theorized from their discovery. His name was Fritz London. Let's look at them. They're called the London Force. It's not named after the capital of the UK. That'd be way more cool. What?
Capital of lost key. You don't get it, because English people is like the stereotype.
English people. Anyone from the UK that watches this later? I'm sorry. Be nice. So, make a note though for the London forces. These are non-polar molecules and then also polar molecules. London forces affect all of them. So make a note for this one. London force is the weakest intermolecular force, but it affects all of them. Every single one of them. Deep breaths, Chris. All molecules, polar and non-polar molecules form. No, this is because of the electron. Raise your hand. Yes.
I remember this in physics class.
Yay!
Don't.
It's okay. So, make a note of it on the bottom of the page 140 that London forces affect all molecules, polar and non-polar. They're the only type of intermolecular forces to affect a non-polar substance. So make a note for them. London forces affect everything. So make a note for them.
You need to know that it affects all
All molecules? Yes.
atoms, polar and non-polar.
Yes. Make a note that affects everything.
Even though it's not italicized.
It's on the bottom of page
Yeah, but that one
140.
says London forces only the type of intermolecular forces that affects non-polar molecules. That's
Alright.
what's in-
And then read the next sentence right underneath that.
That's the only. That's the only.
Okay,
that's the
read
only-
the sentence again.
London forces are the only type of the only type of molecular forces that affects non-polar.
Alright, now read the sentence above it as well.
That is in the top.
But it's London
Just
forces.
London forces is the top.
So read the whole sentence because that's the definition
I
of
already
London.
marked it. I know what it is. I was just saying it.
You have to know the sentence though. Because the idea of it affects all of them, polar and non-polar.
On the theoretical quiz.
This might be on a theoretical exam, so you know it.
What
Yeah.
is this? Wait, I have a question.
Okay.
Don't you get like an hour and a half or like 2 hours review before the exam?
It depends on the day. This exam comes early in the week, and so because of that, we start reviewing earlier, but it's for smaller chunks of time.
Because I know, once
Right, right, okay.
once you take the chemistry exam, you don't come back to chemistry ever.
I think you come back for like 15 minutes to go over the exam because they'll talk about it after Christmas. But you know how fast we go over stuff. So for us, it's mainly for classes like Mr. Nadaski where it's a lot of math. We have to explain stuff. For my classes, it's basically look at it. Any questions? All right, give it back to me. All right, now we can sit around and talk for like 10 minutes while we wait for the next one. Or y'all can study for your exam. Yeah. So that's why this is why for those it's really quick for me. So it's really fast. Alright, so make a note for that though. So, London forces affect all molecules, polar and non-polar, all of them. It's also the weakest intermolecular force. It doesn't tell you this on this page, but it tells you on a later one. So just make sure that you know it's the weakest intermolecular force for it. Alright, so what causes it? It has to do with the electron cloud. What's an electron cloud, Ethan? It's Ethan's turn. Alright, so your book points out, so I just have the electrons. It tries to show you this model on the top of the page, but it's not super clear what they're trying to show, that are the electrons still? No, they're constantly moving. So because of that, there is a chance of as they're moving around, you're gonna have more electrons on one side than you do on the other. If I have more electrons on one side than on the other, what's gonna be the charge of the side that has more electrons on it? Negative. What's gonna be the charge of the side that has less electrons? Positive. Now keep in mind, all the electrons are shifting and moving around. It's because of that. It's only there for like a brief moment of a second. So because of that, they're all shifting all the time. So because of that, you're gonna have the temporary dipole of the atoms. Even if it has something like this, where it's in some sense that is tetrahedral, that you're gonna have it to where as the electrons are shifting, you're gonna have those partial positive, partial negative. They'll be partially attracted to each other for just a split second, and then they move apart again. So that's what causes substances that are even non-polar. I know, they're being dramatic now. To be attracted to each other. And that's the reason why. I've been showing this is very brief. This doesn't happen over and over and over again. That's the reason why you have a substance that's even non-polar, like a tetrahedral substance. Deep breaths, Ethan.
No, I'm not.
Alright, almost out of time though. So anyone have any questions though about this form, with the idea of the dipole-dipole forces? So that's why the effect ultimate is because of the electron cloud. What if I have a larger atom that has more electrons? Do you think its London force will be stronger or weaker? Stronger, because there's more electrons to get there's more electrons to get absorbed.
More is
I bet
better.
what?
More is better.
You can do it that way too. Alright, this is dipole-dipole forces again. I meant to show this earlier and I forgot. Just showing you how you're gonna have the positive and negative ends orient themselves, and this is for dipole-dipole. Now remember, dipole-dipole only affect what type of molecules, Ethan?
Is that actually how it looks?
Not exactly. This particular one, I think they drew it accurately. We're gonna
That's
talk
so
about
weird.
water. Water forms, that's how come water forms up whenever water freezes. It forms up a snowflake, like six-sided pattern, is because of how like that angular shape makes them form up for it.
That's really weird.
It does. But keep in mind, what type of molecule does dipole-dipole affect? Polar or non-polar or all?
Non-polar.
Guess again.
Polar.
Polar. Alright, we'll stop there. Your homework is to read Lab 13. Read it if you want to get started on it, because most of it you can start on your own, because you're just writing off the Lewis structures and saying, okay, what's the shape, and then say, okay, is it polar or non-polar? So if you want to start it off, you can. Tomorrow, you're going to build the molecules. Jamie, I'm going to start recording a YouTube video tomorrow to go over like the homework for the next night. So you're going to watch the Abeka video, and then you watch my explanation for it. But that's basically it. So log in tomorrow, watch my video, and then go watch the Abeka one for you. But that's all your homework for. But this one is graded. You got to do front and back though. So don't just think, wait, hang on. You're going to do front and back, Jamie. So just make sure you're doing all of them for it. Okay. Now, good question.
Turn on Monday.
What? Yeah, you're turning on Monday.
Cool.
So make sure though you read through it, because again, I don't have a whole lot of time to answer questions tomorrow.